Welcome to Lesson 3.1, Fractions to Decimals. So we're starting a new unit, and Chapter 3 is on fractions, decimals, and percents, and the relationship between those three concepts, and they are very closely related because all numbers can be represented as a fraction, as a decimal, and as a percentage. But this lesson, we're just focusing on how to turn a fraction into a decimal and use different patterns to convert between a fraction and a decimal.
So before we get into any specific examples, I've just written a little kind of note here that any number can be written as a fraction or a decimal. So our counting numbers, like 1, 2, 3, 4, 5, and so on, those are all considered whole numbers because they're not represented as a fraction. But what a decimal allows us to do is to write numbers of all different sizes, so numbers in between those whole numbers, essentially. And basically, a fraction and a decimal is just another way to represent the same number. So for example, if I write the number 3, I know that's 3 whole units, I guess. As a fraction, for any whole number, this rule applies. A whole number over 1 is how you would write that number as a fraction. So 3 is equivalent to the fraction 3 over 1. And because if we recall, fraction is just your numerator divided by your denominator. So if I divide 3 divided by 1, I know that equals 3, so that makes sense. And the same thing applies for decimals. Any whole number as a decimal is just 3.0, or whatever your whole number is, 0.0. Because this as a decimal represents I have 3 wholes and no fractional parts. So now it's your turn to do a quick example. If I give you the number 5, and I say I want you to write the number 5 as a fraction and as a decimal, what would you write? So looking at this, I know that 5 is a whole number, and looking at my prior example, 3 is a whole number. So I know that any whole number divided by 1, or over 1, is how I would represent it as a fraction. So 5 over 1 represents my fraction because I know that 5 divided by 1 equals 5, so that makes sense. And then as a decimal, I know that there's 5 whole parts and 0 fractional parts, so as a decimal, my 5 represents 5.0. So before we move on, let's just get comfortable with some of the vocab and some of the terminology in this section. And the two that I want to point your attention to is a terminating decimal and a repeating decimal and what that means. So when you think of the word terminate, what do you think of? You might think of the word stop or end, and that's exactly what a terminating decimal is. A terminating decimal is just any decimal that has an end point or that stops. So for example, 0.25 would be an example of a terminating decimal because it stops. And I know as a fraction, whoops, that represents 1/4. So if I was to go 1 divided by 4, whether I did that using long division or just typed it into my calculator, I would get a terminating decimal. Or if I was to write 0.1, that would be a terminating decimal because it stops. And as I used in my previous example, we know as a fraction that's 1/10. So those are two examples of terminating decimals, or they end, or they stop. There are some decimals that are repeating, and repeating just means they follow a pattern and they go on and on and on and they don't stop. So an example of a repeating decimal might be something like if I have a fraction 4 over 33. And I either use long division or I type that into my calculator, I will get a decimal that looks something like 0.12121212. and it will go on forever. Obviously, your calculator doesn't show it going on forever because it has to stop at some point, but you can see that there's definitely a repeating pattern. There's a pattern going on in these numbers. And what is repeating in this decimal? The 1, 2 is repeating. So a shorter way to write this would be 0.12. And if you just put a line above whatever numbers are repeating, that will tell me that I know that the 1 and 2 is repeating. So if I was to write it out, it would look like 1, 2, 1, 2, 1, 2. A second example of a repeating decimal would be the fraction 73 over 90. So if I was to just plunk that into my calculator, I would get a decimal that looks something like, 0.8111111, and so on and so on. So that 1 is repeating. Is the 8 repeating? No, there's only one 8. It is the number 1 is the number that's repeating. So I would write this as 0.81, and then I would just put the line over the number 1 to indicate that that 1 is the number that's repeating. If I put it over the 8 and the 1, I would make the assumption that the 818181, but because we just have our 1 in this example, we just put that line over top of the number 1 to indicate that the 1 is the number repeating in this decimal. So those are just a few quick examples of the difference between a terminating and a repeating decimal. So just like I mentioned in the previous slide, a fraction illustrates division. So if I have the fraction 1 over 10, that illustrates 1 divided by 10. That's all a fraction is your numerator divided by your denominator. So the fraction 1/10 represents 1 divided by 10. So taking it the next step and saying, how do I get my fraction of 1/10 into a decimal? I know that I have to go 1 divided by 10 because that's how I get it into my decimal form. I just divide 1 divided by 10. So I can do that one of two ways. I could type into my calculator 1 divided by 10 and I would get 0.1. Or I would use long division to figure this out. So if I go 1 divided by 10, and then I just go through the process of long division, how many times does 10 go into the number 1? I know that it goes in 0 times, and then I'm going to go 0 times 10. I know that's 0. I'm going to subtract. 1 subtract 0 is 1. But I have this remainder, and I want to do something with the remainder. So because there are no more numbers left to divide by, that's when you add your decimal, and then now I can add an extra 0. But if I add my decimal in my actual equation, I have to add it to my answer as well. So now I have an extra 0 to bring down, and you can add as many zeros after the decimals you want, but the 0 is the only number you could add. So now I can continue with my division. How many times does 10 go into the number 10? I know that it goes in 1 time. 1 times 10 is 10. And then if I subtract, I'm now left with the remainder of 0. So my answer here, 0.1, is the same as my answer there. So if you are given a fraction of any sort, like we've done here, 1/10, and you're asked to turn it into a decimal, all you need to do is divide your numerator by your denominator, and that will give you your fraction. So in this case, we know that 1/10 is equal to 0.1. So those two things are equivalent. It's the same number, it's just written in two different forms. So we've talked briefly about how to turn a fraction into a decimal, and we're going to go over a couple more examples in just a couple minutes before we wrap up. But we also need to talk a little bit about how you turn a decimal into a fraction. So we're going to do one example together. So if I have the decimal 0.9, and my question says, how do I turn that into a fraction? There are just some steps you need to follow in order to do that. So the first thing I'm going to start with is putting my decimal over the number 1, or creating, I guess, a fraction, because like we've talked about in the previous slides, any number over 1 equals itself, because any number divided by 1 always equals itself. So my first step is to take my decimal and just put it over the number 1. And essentially I'm trying to create an equivalent fraction to 0.9 over 1. And I want the bottom of my fraction, of my new fraction, to equal 10 or 100 or 1,000 or 10,000, because those are the easiest kind of numbers to deal with. So I'm going to look at this number 1 and I'm going to say, okay, if I want to try to create a fraction and I want this denominator to either equal 10 or 100 or 1,000, what do I have to multiply this 1 by to get that? And so that I know if I multiply 1 times 10, I will get 10. So if I go 1 times 10, I know I will have a denominator of 10 on this side. However, whatever I do to the denominator, I have to do to the numerator. So I'm also going to multiply 0.9 times 10, and that gives me 9. So you can just plop that into your calculator, or you can write it out using the long way. So essentially, my decimal of 0.9 is equal to the fraction 9/10. And if you wanted to double check that, if you type in your calculator 9 divided by 10, you should get that decimal. I do, however, want to do one more quick example with you, because sometimes you'll need to think about another number besides 10 to multiply your denominator by to get that equivalent fraction. So if we look at the example 0.26, and I say I want you to turn that decimal into a fraction. So my first step is putting my decimal over the number 1, and I'm trying to create an equivalent fraction. And again, remember, we want this denominator to equal 10 or 100 or 1,000. And what we need is for this decimal on the top, we want this to become a whole number. We don't want a decimal in our new fraction. So if I follow the same steps I did in my first equation, and I see that I multiply this by 10 and this by 10, and I try the same thing, so I'm going to go 0 times 1 equals 10, and then 0.26 multiplied by 10 equals 2.6 if I type that into my calculator. This I do not want, because this still has a decimal in it, and I don't want a fraction with a decimal in it. So essentially this is no good, and I need to rethink what I can multiply it by. So I'm just going to erase that. So what I can do next is, if I know that multiplying it by 10 didn't work, what if I multiply it by 100? What happens then? So if I go 1 multiplied by 100, I get 100. And if I multiply 0.26 by 100, I get 26. So, do I see a decimal in my new equation? No, I don't. So therefore, this works. So I know that 0.26 is equal to 26 over 100. So it's just important to remember that when you are multiplying your denominator and numerator by either 10 or 100 or 1,000, that you do not have a decimal in your fractional answer. So just before we head off, there are some common fractions and decimals that at this point you should be pretty aware of. And if you're not aware of them at this point, it takes practice and it takes just a little bit of memorizing, but these are kind of common ones that will come up all the time that you shouldn't necessarily have to do the math for. These are ones that you should pretty much just know. So if I give you the fraction 1 over 2, and I say, what is that as a decimal? So I know that's 1/2. I know that equals 50%, and so you should know that that just equals 0.5 as a decimal. That's a pretty common one, or 50%, like we already said. If I give you 1/4, so I think of quarters in terms of money. If I have 1/4, how much do I have? I have 0.25 or I have 25%. That's a pretty common one as well. If I have 3/4, how much do I have? I have 0.75 or 75%. If I have 1/3, this one's still pretty common, a little bit less. I have 0.333 repeating, or 33.3%. If I have 1/10, I know that I have 0.1 or 1%. Sorry, 10%. 10%. So those are kind of the common ones. I know there's probably more. And again, if we're thinking equivalent fractions, we know that 5/10 also equals 0.5 or 50%. We know that 2/4 also equals 0.5 or 50%. But for the most part, the 1/2, the 1/4, the 3/4, the 1/10, the 1/3, those should be ones that you just know, so that when these questions come up, you don't need to use your calculator, or you don't need to do the long division or do the math for it. They should just be ones that pop into your head. So if you don't know these, you might want to take some time just reviewing them and practicing them and studying them so you do know them. And the more you practice them, the easier it comes.